Welcome guys today to the AI Club once again, and thanks for joining this evening before the schedule. And once again, I'm your host Shailendra Kadre. Today we will, after finishing probability, we have finished, and now we will start with our simple statistics lecture. Okay. Distribution, like as I have been promising you for many days. Today we will start with some simple distributions, probability distributions, and we'll be having these things. Uniform distribution, student distribution, then normal skewness, kurtosis, and right and left skewed distributions and cumulative distribution. So this is the basically couple of lectures we'll take up on distributions. Okay. So all the important are very more rather than important, I would say more commonly used distributions will finish in our course. And there are so many distributions, as I showed you in previous slides also. There are so many distributions. So everything is not required and everything it is not possible to cover also. Because ours is not a statistics course. Ours is a statistics for data science course. Okay, so for data science, if you know normal distribution, students t distribution, then uniform distributions and couple of more. I think that is more than enough for data science. Okay, so let us get straight into our lecture. So, you see something right on the board, like on the screen, you can see something. So, you will wondering why, without starting any definition, like Shailendra has started just with some data and all. So, we are dealing with data science. So, data, right? Nothing new in that. So, what is this? So what is this? This is the table. You can see the simple table. And I am manufacturing some bolts in my factory. Some lathe machine. I'm manufacturing some bolts, long bolts. And I'm measuring their diameter with the help of vernier caliper. Everybody knows vernier caliper because we have learned it in our physics lab. So that with the help of vernier caliper, if you have forgotten, it is nothing but to use to measure length. So diameter also is a kind of length only, right? So diameter of bolt. I'm measuring diameter of bolt, and it is also you can see the kind of length. Okay. So I'm measuring bolt, and as you can expect, I want to manufacture bolt of 12.5 mm. My precise size should be 12.5 mm. But my machine, because of wear and tear of the tool or some inaccuracies in the machine or some operator errors and all that, my bolts are never produced, say 12.5. Okay, so I have some deviation, and this is just an example data. So in practice, deviation is not that much. Deviation is only in 0.01, 0.02, 0.03 millimeters. But here, just for the sake of some example, I have taken data which is varying widely. So now see the first row actually. So I'm getting first bolt and a couple of bolts I am taking for taking and measuring them. So I have taken a lot of 55 bolts and I'm measuring them. Okay. So what I see between 12.1 to 12.2 kilometer, sorry, 12.1 and 12.2. From 12.1 up to 12.2, I get 4 bolts. From 12.2 to 12.3, I get 21 volts. From 12.3 and 12.4, I get 50 volts. You can see that. Frequency is nothing but your number of volts, which I am getting. So this is a range, and for all this range, I have some data cell like I'm getting between 12.5 mm to 12.6 mm, I'm getting 41 volts. Okay. So like that, I have a tabulated there. So what we have done? So last column, as you can see, is the frequency. Frequency you can easily determine is nothing but number of bolts in that range. So that is frequency. Mid size, so mid size means 12.6 is the lower range and 12.7 is the higher range. 12.7 is the higher range. 12.7 is the higher range. And so mean you will get 12.65. 12.65 is the mid range. Okay. So 12.65 we get mid range. And so mid range is as if you determine the arithmetic mean of 12.6 and 12.5. So 12.6 plus 12.5 divided by 2. I am reading the last record. 12.6 plus 12.7 divided by 2 is 12.65. Okay, so that is our my mid range. So I'm finding this. Now, if I plot this, I get a frequency plot. So this frequency plot we have discussed earlier also, but like people have a tendency to forget many things, so I am repeating it because it is important for our lecture. So like that I have plotted. So what I have plotted, x-axis, I am plotting range 12 to 12.1, 12.1 to 12.2, 12.2 to 12.3, 12.3 to 12.4, and so on. That I am plotting on x-axis. Range I am plotting. And the frequency, if frequency is number of volt, which I am getting in that range, I am plotting on y-axis. Okay, so you can see I am getting this bar chart. Okay, so that is nothing but my frequency chart. So anybody having any challenge in understanding, has everybody understood how I plotted this frequency chart?
Yes, sir.
Simple,
Yes, sir.
right? Between 12.1 and 12.2, I have around 3 or 4 volts. So my bar chart is small. And between 12.4 and 12.5, I have highest number of volts. So it is more than around 72, 73 I have. So I have the biggest bar there. And if you see bar chart, if I approximate that bar chart, I can draw a simple dotted line which you can see. So that is the curve. So the bar chart is the actual chart, but I am approximating it with the help of this dotted line. So I'm making it little smooth, looks better, and like it conveys more meaning than the bar chart. So I'm plotting a dotted line here. So that is my approximation. Smooth line I'm drawing between the bar tips, and this dotted line is coming. So this is my frequency chart. That is our first definition for today. We have learned how to draw a frequency chart. So frequency chart is nothing but you take the range, find the frequency, and then you on the x-axis you plot the range 12, 12.1, 12.2, 12.3, 12.4, 12.5, 12.6, and 12.7. And in between them, how many number of bolts are falling, that you can keep on plotting. So you get this kind of bar chart. Okay, so this kind of bar chart is there. And I can approximate it the value of this dotted line. So this is nothing but my frequency chart. Now, what if I show you this particular, see this frequency chart I have shown you. Now, same chart I am showing you in a different way. So now I am taking a different example of suppose a statistics guy or any mathematician has gone to a very densely populated place in Mumbai. He has collected, say, 55 students. He has randomly taken 55 students. And their age, he asked everybody's age. So, like people with age 2, frequency is 3. Means there are three children with frequency. There are 3 children with age 2. There are 5 children with age 3, as you can see in the chart. There are 8 children with age 4. You can read the chart, right? First 2 columns. There are 11 children with age 5, and there are 11 children with age 6. You can see that. Okay. Now I am see the last chart now, empirical probability. How I am calculating probability? First of all, I have totaled up all the frequencies. Like I have taken 55 students. So all my frequencies, if I add up, they add up to 55. Add up means frequency meaning my total number of students are 55. My total sample space is 55. All students add up to 55. Now what I have done, each of the frequency I have divided by total number of the sum. a total number of students, a total number of children. So 3 divided by 55 is nothing but 0.0545. Then second is 5 divided again by 55. Then it is 0.0909. Then 8 divided by 55, 0.1454. 11 divided by 54, 0.2. 11 divided by 54, 0.2. So on and so on. The formula is given on the right hand side. The frequency of that particular age group divided by total number of people. So everybody understood how I have arrived at this chart?
Yes, sir.
Everybody
Yes.
got it, right?
Yes,
Like
yes.
Karthik and Jignesh also, you got it,
Yes.
right?
Yes.
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 So it is very simple that how we arrived at this chart. So now in place of this chart, bold kind of chart, see I can plot a frequency like this for I done for bolts. I can draw a frequency chart for the children also. Okay. The children also I can draw a frequency chart, but I don't do that. What I do, I take this age 2, 3, 4, 5, 6, 7, 8, 9, and 10, plot them on x-axis. And these probabilities I found plot on y-axis. So like this, see. So first of all, I have done frequency distribution. So 2 means I have around 3. Age group of 3 means I have around 5. Age group of 4 means I have around 7. Like that, I have done the frequency chart. You can see the frequency chart. This frequency chart is very similar to our bolt one, what we have done for the bolt. In the case of children also, it is very similar frequency chart. Okay. Now, now I plot. I don't plot frequency. I plot the probability. The last column. H2, what is the probability? H3, what is the probability? H4, what is the probability? Like that I have plotted. So I get this probability chart. So you can see that my probability is varying between maximum value of probability is 0.2 and minimum value is 0.018. 0.018 and maximum value in this column is around 0.2. Okay, so I do that. I do that. Okay, so frequency chart also I have plotted. Now one thing to notice. So one thing to notice. This is frequency chart. See the shape. If I join the tip of all these columns, I will get a bell curve, inverted bell curve, okay, which is our normal distribution. And if I join this also, so both the charts look exactly the same. Frequency chart and probability chart both look exactly the same. So there is a reason to it, right? Because proportion is the same. Okay. So these two charts are there. Only y-axis is differing, but charts is exactly the same. Chart is exactly the same. Okay. So now you understand how I draw a probability chart and how I draw a frequency chart. Has everybody understood that?
Yes, sir.
Yes, sir.
Yes,
Karthik, you understood that, right?
yes, sir.
So now you will find that so frequency chart is exactly similar to your probability chart. Only y-axis we have varied. How we have calculated y-axis I have shown you here with the help of the chart. So this is called our probability distribution. That probability chart, that what we have drawn that is what is called a probability distribution. Now I ask you a question. I have total 55 students here, 55 children here. What is the probability of me finding, with the help of this chart you have to tell, what is the probability of me finding is a child of, I pick up a random child out of 55. What is the probability of me getting a child with 3 years of age? Read this chart and tell me. What is the probability of me getting a child with
One.
3 years of age?
0.1.
1.
0. Around 0.1,
One.
right? Approximately, you cannot read it exactly because exact values are not given. There is a range given, right? So around 0.1. So what is the probability of me getting a child with out of 55? Again, I take a random student, a random children, random child. So what is the probability of me getting a child with 88 years of age?
0.9.
0.9. Okay, so approximately same. It is symmetrical, right? So around 6 is the mean age. 6 is the mean age, and around 6 left and the left and right, this chart is symmetrical. Curve is symmetrical. Okay, so this is the natural phenomena. What I have done, 55 students I have taken. I had taken from a random densely populated area, 55 I randomly took, and I asked their age. So this is a natural phenomena kind of thing. So I'm getting it is normal distributed. And mind it, instead of asking age, if I measure their height, that also will be there in the and plot a frequency chart and probability chart like this. That also will be normally distributed. Means it will be in the shape of a inverted bell curve. It's in the shape of a bell curve. If I measure their blood glucose level, so that also will come in the same shape, similar shape, bell curve. So it's a phenomena. So like many random phenomena, social phenomena, and natural phenomena, they tend to follow a random distribution. So now you are clear how to plot a frequency chart and how to plot a probability chart. You are clear?
Yes, sir.
Yes.
So
Sir,
this is our probability distribution.
sir, sorry, sir. I mean, I have one question.
Yeah.
So,
So no, why sorry? You tell me the question.
sir, probability distribution, I understood. I mean, but frequency distribution, I mean, you said that that
Why
distribution.
frequency distribution? See here.
Yeah.
See here. Frequency distribution is you understand. Between 12.1 to 12.2, I have 4 bolts. Between 12.2 to 12.3, see the last one, I have 21 bolts. Between 12.3 and 12.4, I have 50 bolts. So I plotted them. So
This
see,
is,
between 12.2 and 12.3, I have around 20 bolts, 21 bolts. I plotted them, simple, no?
yeah, this is I understood, sir. So,
Then this is frequency chart.
so frequency, if it is given, then only we'll be able to plot the chart, na?
Yes,
Okay.
frequency should be given, or we have to measure the frequency.
Yeah, that is.
I should be given already. And
Okay.
once frequency is given, we can total up and then find the probability chart. Right? Right?
Right. Sir.
So individual frequency divided by total frequency, that will be the probability, right?
Understood. Sir. Yeah.
So that we can plot. So frequency either should be given or as a scientist, we are measuring it. Okay, so frequency is must. So you will find that from, as I said, frequency chart and probability chart for the same thing, for the same experiment will be exactly same. Only y-axis measurement will be different. So now today our subject of study is this probability distribution. So first, before starting, I wanted to make you clear that what is a probability distribution, because many people learn normal distribution and ask them. If I ask them what is how this normal distribution curve is plotted, they are not able to tell it. They are not clear how it is plotted, what is there on x-axis, what is there on the y-axis. That's why we have taken up first how it is plotted. Is it understood? Any more questions in this?
No, sir.
Ignesh, Karthik, you understood how a probability distribution is plotted, right? Right?
Yes.
Now, what is normal distribution? So, normal distribution is something, again, I am taking you to a Investopedia definition, which is some definition is given. I don't want to confuse you. Like anything, which any probability distribution, which everybody has seen temple bell, right? Temple bell or church bell. Everybody has seen, right? The
Yes,
shape
sir.
is very much like this, right? So any probability distribution which matches with a bell curve, with a bell, is called a Gaussian distribution. It is called a Gaussian distribution. Any probability distribution means the distribution we had plotted here, like this distribution curve. Any probability distribution which matches with a bell is called normal distribution. So is it a normal distribution or not? Tell me this one. Is it a normal distribution?
Yes, sir.
Yes, sir.
Why is it a normal distribution?
If we just put the curve, then it will be in the bell shape.
Bell shape. So it will be little flat bell, right?
Yeah.
Little spread out bell, because standard deviation is more. So it is a spread out bell. Age is spread out between 2 and 10. If their ages are age is 2.5, age is between 2 and 5, so this spread will be less. Bell will be more vertical, more sharper. Okay, so got it, right? So I'm not taking you to the definition because we are not appearing for any exam, and you understood, I think, what is a normal distribution. So now we will study some properties of normal distribution. So first of all, I won't don't look at any figures in this. We'll see it in the one of some more upcoming slides. We'll see. So anything which matches with a bell curve is called normal distribution. So now you can find out one thing. Mean is there in the middle, right? Mu is there in the middle. Okay. So mu is the highest bar, right? Mu is the highest bar. Middle one is the highest bar, right? So you can say that mean, median, and mode. Mean, median, and mode I explained to you a couple of class before. So for this, mean equal to mode equal to median. That is first property of a normal distribution. See, because highest frequency only will yield highest bar. Got it, no? Vignesh.
Yes, sir.
Yes, sir.
Highest frequency term only will get highest
Median.
bar, right? So it will
Yes.
be in middle.
Yes.
So middle. So for normal distribution, mode equal to mean equal to mode and equal to median. Mode, median, and made are same. So it is in the middle bar. So that is the first property of property of a normal distribution. So as I said, as I said you, as I told you earlier, many social and random phenomena, natural phenomena, they tend to follow this kind of bell curve. So this is most important. This normal distribution, it is also called Gaussian distribution. It is the most important distribution studied in the world of statistics. That is one thing. Many social phenomena, random phenomena, or many say natural phenomena. If you don't know their distribution, you can model them with the help of Gaussian distribution. Okay, Gaussian distribution on natural this kind of Gaussian distribution or what is called as normal distribution or Gaussian distribution. Okay. So now what is modeling will come to know later. So now see here. Here when we are finding the age of students, age of children, and then they are finding their frequency and then their probability. That means we are modeling this particular age. So some properties you will come to know. Like I will tell you later. So some properties are there, and it is the importance of Gaussian distribution or normal distribution is partly due to central limit theorem. So central limit theorem we had studied yesterday, and it is one of the most important theorems in statistics. So that also, like we foresaw that if we take random samples, say suppose there is a population whose distribution we don't know, and we take 20 random samples, and find out their means and find their probability distribution, it will follow the normal distribution. So that's what is central limit theorem we studied yesterday, right? So importance of importance of normal distribution or Gaussian distribution is partly due to central limit theorem. So that is one thing. First thing of thing. Then probability distribution, another property I want to tell, it is for a continuous number. Okay, it is for a continuous number because if you study this data, like this data, if you study, so bolt diameter can be any point. It is with decimal point. So with decimal point, I can have infinite ranges like this. So it is for a normal distribution is always for a continuous number. And age of the students here I have taken as whole number. But I can take 1 year, 1 month, 1 year, 2 months, 1 year, or 2 months, 51 days. Like that, I can also take a plot and plot very dense probability distribution. So it is always for a it is a continuous distribution. Natural normal distribution or Gaussian distribution is a continuous distribution. That is another property. Okay. Now, and this curve which we see, the bell curve, it is called a normal curve. It is given definition as a normal curve. It's a definition, name given to this curve is a normal curve. Okay. So now let us see another property of this normal curve. So this this normal curve we can find out to find the probability. So how we can find out probability? So see, if I ask you a question that how many students, what is the probability of getting a student between age of 4 and 8? So this probability you can compute with the help of a normal distribution, which we found. So what is the probability of getting a child between 4 to 8? What is the probability of getting a student less than 8? What is the probability of student whose age is more than 8? Getting a student with age more than 8. So these kind of questions you can answer with the help of this normal distribution. So how this is we'll see shortly. We'll see how we can answer this. So first of all, area under the curve represents the cumulative probability. I'll tell you what is cumulative probability. So cumulative probability means probability of getting a student of age less than or equal to 5 means I want students with age 0, 1, 2, 3, 4, 5. So from 0 to 5. So that probability, total probability which I get, so that probability is called cumulative probability. That we can get with the help of area of this curve. So we'll see that. We can, with the help of area under this curve, will tell you the cumulative probability, first of all. And total area under this curve, which is shaded light blue, that is 1. Because probability cannot be greater than 1. So cumulative probability also cannot be greater than 1. So total area under the curve is equal to total area of under the curve is equal to 1. Okay, it's equal to 1. So now total area equal to 1. Then now it is something more properties we'll study. That suppose our mean is 0. Suppose we have a normal distribution whose mean is 0, means some terms are positive and some terms are negative. When we add up and divided by the total number of numbers, so that mean comes 0. Because some numbers are positive and some numbers are negative. So if I take the mean, it is coming 0. Suppose there is a case like that. And we have plotted it with that probability distribution we have plotted. Okay. So now, so this property we have to study, that this is the property of normal distribution or Gaussian distribution, that with mean is 0. Okay, you can see the mean plotted. This curve, mean is 0. So with standard deviation 1 and 2, 1 and minus 1. So standard deviation 1 and like it is not it is not there is a misprint actually. So on the left side it should be 0, minus 1, minus 2, minus 3. It like 0, then minus 1, then minus 2 and minus 3. So there is a misprint here. So please correct it. So in left hand side of the 0 it should be 0, then minus 1, then minus 2, then minus 3. So instead of minus 1 they have taken minus 2. So that's a misprint actually. So don't get away by misprint. So between standard deviation and minus 1 and 1 standard deviation, between one standard deviation plus standard, so like from 0 mean, if I go right hand side to one standard deviation and left hand side to one standard deviation, so that's where my 68% of the data lies. That's where my 68% of the data lies. And if I go 2 standard deviation on the right and 2 standard deviation on the left, and 90% of the data lies there. And if I go three standard deviation right and 3 standard deviation on the left, then I have 99.7 99.7% of data lying between these limits. So that is 1 sigma, 2 sigma, and 3 sigma. So you might have studied a lot of theories about 6 sigma. So 6 sigma is nothing but 3 standard deviation from the mean towards the right and 3 standard deviation from the mean towards the left. That is 6 sigma. So 2 sigma means one right, one left. That is 2 sigma. 3 sigma, like 4 sigma means 2 right, 2 standard deviation right, and 2 standard deviation left. So total 4 sigma. So now actually I planned today to explain you what is standard deviation. So instead of explaining you normal distribution, it's better that I explain you first standard deviation and correlation. Standard deviation and variation, variance. So these two things I wanted to tell you because I don't think you all the guys here are familiar with what is standard deviation. So I will deviate from the route, like slightly I will deviate from the route, and give me a minute. We'll go to like I will search example of numerical example of standard deviation and explain it. Give me a minute. I will search on Google numerical example on okay. So I got here something. So my screen is not shared, right?
No, sir.
I will share my screen. I share my screen. Share my screen. Share. Okay. So now you can see my screen, right? So I
Yes,
got
sir.
here one example. So first of all, credit to like byju's.com. Okay. So it is from byju's.com. Okay. So now we have like there is a variable like I explained you already that a variable in data science means always having multiple value, and a variable in algebra or some other mathematics x equal to 5, so it will have a single value. But if I say variable age data science means it is a data column, complete data column, I am calling it as a variable. Okay, so age means there will be multiple, there will be 20, 30 or 40 entries of age in that. Okay, is that understood? What is the difference between variable in a data science and variable in a simple algebra? Is it understood?
Yes, sir.
Amit and Karthik, is it understood?
Yes, yes, sir.
Yes, sir.
So I have a variable x in data science. That means I have a complete column. I have multiple values of x. X1 is see, you can see here. I will little bit. You can see here, right? So like there are 4 values of x. One is 4, x1 is 4, x2 is 2, x3 is 5, x4 is 8, and x5 is 6. So let us find out first. Mean, you know how to calculate mean. So you add 4 plus 2 plus 5 plus 8 plus 6 divided by total number is 5, no? So 5. So here sigma x divided by n is the formula for sigma x plus sigma x means you add up all the values are all the values in x and divide by the total number. So you find out, so 4 plus 2 plus 5 plus 6 plus 8 divided by 5. So it comes out to be 5. So mean is 5. You got that, right? Now you are now you have to do what you have to do, like mean. So mean is represented by x and bar on the top. So this is your mean. So this is what I'm highlighting here. Not allowing me to choose. But X bar you can make out, right? X, there is a flat bar on the top. So that X bar is nothing but your mean. Okay. So now what do you do? From X1, X2, X3 and X4, you subtract the X bar. So X1 was 4. So X bar is 5. So 4 minus 5 is minus 1. X2 was 2. So 2 2 minus x bar is 5. So 2 minus 5 is minus 3. X3 was 5 and x bar was also 5. So 5 minus 5 is 0. X4 was 8 and x bar was 5. So 8 minus 5 3. X5 equal to 6 and x bar was equal to 5. So I got 1. So is everybody clear what I have done here?
Yes.
Yes,
What we
sir.
have done here?
Yes, yes, sir.
What we have done, each number we have subtracted the mean value.
Correct. Yeah.
6 minus x bar. That's what we have done, right? So understood? Everybody understood? Jignesh
Yes,
and Karthik?
Yes. Yes.
Now we do this sigma xn minus x bar whole square. That means whatever difference we have taken, we add up all. Okay, so one is minus 1, one is minus 3, one is 0, 3, and 1. So we have done, we have squared up. So we have all the differences which you took, we did the square. Why did the square? Because we don't want to deal with the sign. Minus 1 square also will be equal to 1 only. Minus 3 square will be also 9. So 9 square and minus 9 square will be same only, right? 9 only. So we don't want to deal with the sign. That's why we have done square. So this is sigma x minus x bar whole square. That's what we have done. So that number has come 20. Is this understood? Is this step understood?
Yes.
Is this understood?
Yes.
Understood, na? So now
Yes.
what I have done, whatever I have got 20 here, the sigma x minus x bar whole square, I got 20. I divided it with the help of n minus 1. So what is the value of n here? What is the value of n? How many numbers we have?
5.
5. So value of n is 5, right?
Yes.
So see, simple what I have done, x minus x bar whole square, that summation was 20. That's what we calculated here, right? So that's what we calculated here, right? Here, 20. 20 I divided by n minus 1. N minus 1 will be how much?
4.
4. So 20 I divided by 4. So it will be 20 divided by 4 means 5. So it will be root 5. So standard deviation will be 2.236. Got it? How
Yes,
standard deviation is calculated?
Yes.
So
Sir,
you
last
first
two step I did not understand. So sorry.
which 2 steps from where you are not understood?
So how we got this? I mean, 5 I understood, but how we got this 2.236?
See, 5 means I will explain you again. You got this step.
Yeah, sir. This
5
is
we have
clear, sir.
subtracted from every number.
Yes, sir. Clear.
You got this. So we got minus 1, minus 3, 0, 3, and 1. You got this?
Yes, sir.
Got it? Now
Yeah.
what I do? I square up these differences. Minus 1 square plus minus 3 square plus 0 square plus 3 square plus 1 square. It's written here, you see.
Yes, sir.
Written here. You got it, na?
Yeah, yeah.
So
That
they
20
all
is also.
add up to 20. They
Correct,
all
sir.
add up to 20.
Yep.
Now what I have done, this summation 20, I have divided by n minus 1. So see, in this step, it is written 20 by 4. It is
Yes. Yes.
20 by 4.
Yes. 5.
And then I have taken the square root. So 20
Okay.
by 4 is how much? 5, right?
Yes.
So square root of 5, if you calculate by calculator, it is 2.236.
Okay. Okay.
Now you got it.
Yes, sir. Understood.
So this is called standard deviation. This is how standard deviation is calculated. First step is to calculate mean of the number. Second step is to subtract mean from each of the values of x. Then whatever difference you get, squared up and add, that is third step. And then fourth step is divide by that summation you divide by n minus 1. And fifth step is again there, square root. Got it? How standard deviation is calculated? Have you got it?
Yes, sir.
Yes, sir.
Everyone got it, right?
Sir, one question.
Yeah.
Sir, I mean, curious. I know that, I mean, that will not be the correct one. But let's say, I mean, I counted the number total, and if I take the square root of that, will that work as a standard deviation?
I am not getting your question. Can you
So
please repeat?
I am saying the total n is 5.
5, yeah.
The square root of 5 is 2.236. So will that
Yeah.
work?
No. Square root of n will not. It is just a coincidence here that it is 5 and it is 5.
Okay.
So it will never work. It will never work. So sometime your No, it will never work. It will not work. So you have to go by this formula there. All the steps you have to go, then only you can find out standard deviation.
This we understood, sir. This we understood actually.
Right
I
now,
was
it
just
is just a coincidence that that number is also 5 and this also 20 divided by 4 is also coming up to 5. It is just a coincidence. Okay, nothing else.
okay, sir.
So you found out how to calculate standard deviation. Now, in one of the class, I told you how to calculate variance from standard deviation. Does anybody remember? How to calculate variance by standard
It
deviation?
was square of
Yes,
standard.
square of standard deviation, right? So standard deviation is 2.236. So square will and the what? So what will be the variance here? How much will be the value of variance? Tell me.
4.4.
No. It is in front of you, yeah. Tell me the exact value.
4.49.
Oh no, you just see, you have taken root 5 here, right?
5.
So it will be root 5 square. So root 5 square will be 5, right?
Yeah.
And if you 2.236, also if you square in your calculator, it will sum up to around nearby to 5, approximately, because we have not taken all the decimal points. Na? So if you do 2.236 square in a calculator, it will be around 4.9999 something, very near to 5. Understood, na? So variance is 5 and standard deviation is 2.236. Now you got it. Now I tell me, if variance is more or standard deviation, see both variance and standard deviation represent the same thing. Because just if you say squared up standard deviation, it comes as variance, right? If standard deviation is more, square also will be more. So if standard deviation is more, variance also will be more, right? Correct, no?
Yes.
Yes, sir. Yes.
So now tell me the question, this also we had discussed in the last class, one of the classes, that if my standard deviation here is coming 2.236. So if my standard deviation is in that I got 20.236 of I get. So what is the physical significance of getting standard deviation 2.236 and another data set which I work, do the same steps, I'm getting standard deviation of 20.236. What is the physical meaning of this?
So when we get the standard deviation more, means the ranges are not, I mean, the difference between the ranges will be that salary example you gave. So
Yeah, so difference between maximum and minimum is more.
more,
Data is more spread out.
more.
Yeah.
Yes. Yes.
Data is more spread out, right?
Yeah.
So now here,
Confidence
one
interval
property
is more.
now. Got it, na? If standard deviation means less means data is very nearby to each other. If standard deviation is more means data is very spread out. Got it, na?
Yes, sir.
Now you tell me here, if I come, I take you here. So like shape of my bell curve will be more sharper in the case of standard deviation is equal to 2, or it will be more sharper in the case of standard deviation equal to 20. My bell curve will be sharper. Sharper means it will be a steep mountain. Understand steep mountain, right? Will it be steep mountain in the case of standard deviation 2, or will it be a steep mountain in the case of standard deviation 20?
2 less standard deviation.
Less standard deviation means my bell curve will be steeper, right?
Yes,
Mountain
sir.
will be steeper, right? And standard deviation 20 means it will be more spread out. Understood, na?
Yes,
Yes,
sir.
sir.
So now you understand this point which I am trying to make here, that if 0 is my mean, for example, my data is like that, my mean is 0. Because some values are positive, some values are negative. When I add up, it adds up to 0. Okay. Because positive, negative cancel out, so it adds up to 0. Suppose my mean is 0, and if I go one standard deviation right and one standard deviation left of mean, that means my 68% of the data values will lie there. Understood? If I go 2 standard deviation to the right and 2 standard deviation to the left, my 95% of the data values are lying there. And if I go 3 deviation to the right, to the mean from the mean, if I go 3 standard deviation right and 3 standard deviation left, 99% of the 7 point value lying there. This property, or whatever you see right now on the screen, that will be utilized in the case of some numerical example, doing some numerical example. Understood? Is this understood?
Sir, this is understood, and this is for the normal distribution we are saying.
Only for normal distribution, this we are talking.
Okay.
No other distribution will have this property.
Okay, sir. Yeah.
It is only for the normal distribution.
Yes.
Okay. What time we started, dear?
7,
Exactly 7?
around 7, 7.
7, 5, 7, 10.
Okay, so I'll take 5-10 more minutes and then we'll stop for today.
Sure, sir.
So is this being understood?
Yes.
Yes.
Now, little bit deeper into standard deviation. Now you see, now if I say this curve, some curve will be some mountain of the normal distribution will be steeper, some will be more spread out. So then we should have a mathematical way to represent this curve, right? Yes, or right or wrong? Then only will be called mathematician, right? So we have a mathematical way to represent a steeper curve. How to get a steeper curve, how to get a spread out curve. We should have a mathematical way, right? So that mathematical formula is this. Don't get worried about this formula. Formula is very simple, I will tell you. In that only two variables first not only two variables are there. Y is nothing but your curve, which you are getting. Only two variables are there here. Mu means mean and sigma means standard deviation. Only two variables are there. Rest, one value is pi. Pi means 3.1459. We are all aware from your 5th, 6th class. Value of pi is always 3.14159. It's a constant. The value of E. E is also we are aware 2.7128. That value also from 9th, 10th class algebra, we are aware that pi and E are constants. Their value are constant. You study the formula. 1 upon sigma under root of 2 pi. So under root of 2 pi is nothing but constant because pi is constant. So and sigma is variable here. Now E to the power. E is again constant. E to the power minus of in the bracket x minus mu divided by 2 sigma square. X minus mu whole square divided by 2 sigma square. So x is what? X is nothing but our data point. So x is nothing but our data column. So here then that formula I showed you, age of that person, age of person belong to 2, 3, 4, 5, 6, whatever age. So that x will vary like that. X sometime 2, 4, 5, 6, like that. So that age will be plotted on the x-axis and corresponding value from the y will get from this formula and apply it on the y-axis. So will not that define your curve? X-axis I have age, x. Mu and sigma are known, suppose. Mu and sigma are known. So can I not calculate value of y from here? Yes or no?
Yes, sir.
Yes.
I can calculate value of y, right? So
Yes.
x is plotted on x-axis and value of y I can get from this formula because there are only two variables, mu and sigma. Suppose I have their value given already, mu and sigma. So if I value of mu and sigma for any data column, can I plot that curve or not?
Yes.
Now, this formula you don't have to remember, but you still need to understand. See, if I vary the value, if I vary the value of sigma here, so will the curve vary or not? Or sigma equal to 10, sigma equal to 20, and sigma equal to 30. Three sigmas I have given.
Yeah.
So mu is same. Mu is equal to 5 in all the three cases. Mu is equal to 5. One case sigma is 10, another case sigma is 20, another case sigma is 30. Will the shape of this curve different or not?
Yes, sir.
Different, right? Because value of y you will get is different. Okay. So that means there can be infinite number of normal distribution curve. Some will be steeper, some will be less steeper, some will be still less steeper, some will be flat, some will be more flat, some will be still more flat. There can be infinite number of normal distribution curves. That's what you understand now. So that will depend upon what are the values of sigma and mu. Okay, mu means your mean and sigma means your standard deviation. Got it? Depending upon value of sigma and mu, you can have infinite number of, because sigma is also a continuous number and mu also is a continuous number. So you will have infinite number of, you can have infinite number of normal distribution curves. Everyone's shape will be the bell curve only. Everyone's shape will be bell curve only. Some will be stiffer, some will be less stiffer, some will be flat, some will be more flat, some will be even more flat. Got it, na? So there can be infinite number of normal distribution curves. That's what you understand.
Yes, sir.
You understand that, right? So now in this formula, mu and sigma are variables. So if I want to define a normal distribution, can I not define it the well? If I know the value of mu and sigma, if I know the value of mu and sigma, can't I plot normal distribution curve? Suppose x, for a given x is there. Suppose x is there. Well, suppose x is nothing but your age. So x varies from 2 to 10. That is x. So suppose for a given x, if I know the value of mu and sigma, can't I plot the distribution? Can't I get the probability curve? Yes or no?
Yes, sir.
Yes.
X is fixed. X is varying from 2 to 10. So x I am plotting on x-axis and value of y I am getting from here. And I am plotting a curve. So what I need? I need mu and I need sigma because only these two are variable. Pi is constant, E is also constant. Right now? So any definition for defining normal distribution, you need only two variables. What is the value of mu? Mu means what is the value of mean, and sigma. What is the value of sigma? Is what two variables are needed to define your normal distribution. What is the value of mu, and what is the value of normal distribution standard deviation? So if mu and sigma are given to you, your normal distribution gets defined because you can put them in this formula and get your normal distribution curve, right? So I close it here, and I hope it was not heavy because that is very simple things we have discussed today. So I'll share this PPT with you, and you can sorry about that. I got a little disturbance. So okay. So till that we have studied today. So what is next? I'll start from tomorrow. We'll study some more features of this formula. Same formula. We'll study some more features. So we have a couple of slides on that. And then we will design one more distribution, which is standard normal distribution, which is a special case of normal distribution. The standard normal distribution is a special case of normal distribution. So then we'll go to some numericals and all. Okay. So tomorrow we'll finish our. Tomorrow we can finish our normal distribution and maybe some portion of student distribution will start. So I explained to you in one of the class that if number of samples n, suppose age is a variable, and you have 30 children whose age you are measuring, so 30 or more. So in that case only you will go for normal distribution. Got it? If number of students or number of age n number of sample, if it is 30 or more, then only you will go for normal distribution. If it is 30 or less, there is another distribution which is called student T distribution. That's what we'll go. 20, 25, 15. You have less number of samples, then we'll go for student T distribution. But if you have more number of samples, 30 or more, then you will go for normal distribution. Is this understood?
Yes, sir.
So now we have done around 70% of 60 to 70% of 60% of normal distribution. So I am giving it more stress because it is most important distribution in statistics. So we should understand this formula also in detail. You don't remember this formula, it's okay. Whenever required, you can see my PPT or you can search internet and get this formula. But you should understand what are the properties of this formula, How does it behave under different conditions? What is standard normal distribution? And then you should understand what is Z value is calculated, Z score. And based on Z score, we'll do some numericals. So that's what will close your normal distribution. Okay. So I close here. And till now, if you have any questions, you are most welcome.